Let me on the recording also. So my screen and audio both are okay. Please once confirm again so that we can start the today's
Yes, sir.
session.
It's clear, sir.
Okay, okay. Thank you, thank you. So good evening all, and thanks all for joining this electrical design engineering training program. Yeah, Siraj. Okay, thank you. Yeah, Bharat, it will be recorded. Correct. Yes. So let me take the syllabus. Yeah. Okay. So here we have the syllabus that we are going to follow, and this syllabus have total 25 modules. Okay. So before coming on this syllabus, let us have a introduction session. And actually today we have the introduction session. And before going to the introduction of syllabus and the participant and about the company, let's have an introduction about the electrical power system, and thereafter we'll go to the syllabus and other introduction. Okay, my voice is clear to everyone. Should I need to reach? This is okay.
Voice is clear, sir.
Okay, thank you.
It's clear, sir.
Okay, thank you. So let us start from the introduction of the electrical power system, and thereafter we will come on the syllabus and about the ITP company introduction, about the me, and about all the participant introductions. So, and today agenda is the introduction of this training session. So let me open some presentation about the electrical power system. So when we talk about the power system, so what is your understanding about the power system? What you feel about the power system? So let us discuss on that. And let me tell you the very interesting fact that the basic and final aim of an electrical engineer is to generate electricity, transmit electricity, and finally deliver to consumer, or we can say finally deliver to the individual. And as an electrical engineer, we must satisfy the demand of consumer. And this power system deals with all these aspects of electricity generation, electricity transmission, and distributions finally to the consumers. So that we have the electrical power system. So this electrical power system have total three main components. We can divide like that. So first of all, we generate the power, we generate the electricity. Then after the generations, this is we can refer as the generation stage. This is the generation state. Thereafter, we need to transmit the power. So second stage, second main component in power system, we have the transmission of power, and thereafter we need to distribute the generated power or the transmitted power to final the different end users or the consumers. So this electrical power system have three main components: generation, transmission, and the distribution. So when we talk about the generation of the power, so what is the medium through that we can generate the power? And we have to recall the first law of thermodynamics, that we cannot create the energy or we cannot destroy the energy. So what is the method? The method is only we can change the energy from one shape, from one form to the another form. So what is the uh, power generations medium that we have? So by PPT slide is okay, or should I need to zoom? This is fine. Please
Fine.
confirm.
Fine, sir.
Okay, okay, and my mouse you can also see.
Can you just run it in presentation mode? So it will be more clear.
In the presentation mode. This is not okay. Let me check. Hello.
Yeah.
Yeah, Siddharth, is that okay? Is that fine, or should I need to zoom with this? Okay, let's just
No issues. Okay. Okay. I can manage.
yeah. Now fine, Siddharth.
Yeah, it's fine.
Okay, okay, yeah. So as the first law of thermodynamics says that energy can neither be created or cannot destroyed. So energy can only be transferred or changed from one form of energy to the another form of the energy. So the energy may be the chemical energy, the solar energy, wind energy, or the nuclear energy that we are using at the intake energy. And this generating power plants take these all energy and convert this energy into the electrical energy, into the electrical form of the energy, right? Alkesh, please mute. And these generating power plant, further we can divide into two types of the plant. One is the renewable power plant and the second non-renewable plants are the conventional plant. The renewable power plant uses source of energy like the solar, wind, hydro and the biomass, whereas the non-renewable power plant uses source of energy like coal, nuclear, natural gas, diesel. So these are the non-renewable power plants. And due to the limitation of the power generating resources, for example, if we are doing the genesis with help of the coal, so coal in case of the thermal power plant, water in case of the hydropower plant, the generating power plant is located far away, and that is the point that this uh, transmission and distributions comes into the picture. So generating power plant is located far away from the end consumers. Due to this reason, huge bulk amount of power need to be transmitted from generating plant to the distribution point at distribution substations, distribution point, and required transmission line and the distribution lines. And that is why the transmission and distributions comes into the picture. And through that, the switchyard or substation also comes into the picture. So what is the generating voltage? How much voltage we generate? These with help of this power plant. This is one snapshot of the new thermal power plant. So how much this is solar power plant? So how much voltage we generate? What is my generating voltage?
11 kV, 15 kV.
Yeah, so we can write here my generation voltage. The generation voltage is 11 kilovoltage or 15 kilovoltage. Okay,
6.6 kV.
yeah, 6.67 or 6.6 kilovoltage. Then
Uh, 20 kV, sir.
yeah, 33 kV we can also take 33 kV. So these are my generating voltage. And what is the generating power? What is the generating power that we can take?
6 megawatt.
It is in the megawatt, right? If we talk about the big scale power plant, so it may go around the 100 megawatt, the 300 megawatt,
600 megawatt.
yeah, 600 or 600 megawatt, 660 megawatt, 1000 megawatt, 1500 megawatt. So these are the generating plant megawatt capacity. 132 kilovoltage we not generate, never. Okay, any idea how much we generate with help of the solar? This is not matching with the solar, so I'll come on that. Okay, so due to the limitation of generating equipment size and transport limitations, equipment operation and maintenance limitations, equipment O&M limitations, the generating voltage of the electricity. So why we cannot generate the 132 kilovoltage or 220 kilovoltage? So this is the reason that if for the generation of 11 kilovoltage we take such a huge size of the turbine or the boiler, only we are generating 11 kilovoltage. So if we go for the high voltage or extra high voltage generations, then the plant equipment capacity will increase. So due to that limitations of the generating equipment size, transport limitations of the generating equipment that we use into the generating power plants, equipment operation maintenance limitations, the generating voltage of electricity is in the range of 3.3, 6.6, 11 to 20, 33, whereas the generating electricity power is in the range of 100, 300, 600, 1000, 1500 megawatt like this. Similarly, if when we comes to the solar power plant with help of the solar PV cells, so here we have one snapshot of the solar power plant. I think we have the original drawing also. Let me check if I have the original drawing. Yeah, this is the one original drawing. Capacity is very small, 3.75 megawatt ground mounted solar project, and here this is we have this PV cells. This is PV cells that we are taking, and then we are feeding to an inverter here, and then this AC this AC generating capacity is around 800 voltage. So with help of the solar, generally we with help of the PV cells and inverter we generate in the terms of the voltage like 630, 600, 800 voltage or 1.2 kilovoltage like that. So what we do after the generation of this 800 voltage, we use one step up type transformer that we can see here. This is one step up transformer, and by help of this transformer we are doing step up of this voltage to 33 kilovoltage. So we have input 800 voltage or 0.8 kilovoltage step up to 33 kilovoltage here, and this 33 kilovoltage finally we are feeding to the grid. We are doing the evacuations of 33 kilovoltage. So here we have this generating voltage around 800 voltage, 600 voltage or 1.2 kilovoltage, very less voltage generations we are doing. So generation voltage is less due to the limitations of the equipment that we use in the generations. Thereafter we need we need the step up type transformer where we step up these voltage keeping the frequency and the power same, and to have this step up transformer we need to install the generating substations, we need to install the generating switchyard. So now by this the second problem that we cannot send this much low voltage and this much high power we cannot transmit. So in order to like what are the limitations if we transmit here, so what is the problem, can we transmit
Sir,
this much
loss
power?
is occur, sir. If we provide the low voltage in the transmission system, so more drop is will occur in the transmission system. So
Yeah,
it is
so the
a huge
line
loss in
losses
the
is very much high, the line loss is very much high, the drop in the voltage also very much high, so we cannot transmit this much generating power to such a lower voltage. So since generating voltage level is very less, 33 kilovolts max to max, and these generating stations located far away or remotely from the end consumers. So therefore, if we transfer the bulk power that is in the megawatt at the rate of less voltage, that is 33 kilovolts max to max, from generating plant to the end consumer, since there is a long transmission length to be covered by this low voltage, and at receiving in very low voltage we will receive due to the long length, therefore low power will be received, and due to low voltage at the same time the transmission current will be higher due to the low voltage, that is the reason, and thus the transmission line loss is very much higher because current is higher, so the transmission line loss is very much higher and less power transfer capacity possible by help of the transmission line. So and that we can also calculate that we have this much voltage and this much power, so we can calculate that how much current is coming, right? Now we have just take the power formula, take the power factor, point it, and we can find out how much current it will come, and the current will come very much high, and the losses will depend on the current. So when the current higher, then my line losses will be higher. So what is required now? So less power transfer capacity possible by the transmission line. Therefore, to increase the power transfer capacity and to reduce the line losses, the generating voltage need to be stepped up. As we can see here, the generating voltage we are doing a step up. 800 voltage generated, then we step up to 33 kilo voltage. Similar, we can see. So the generating voltage need to step up for transmission purpose, and to step up the generating voltage, generating substation required, and thus the substation comes into use, or this comes into the picture with step up type power transformer and with associated switchgear to this transformer. And after step up, electricity travel, when we increase the voltage level, then electricity can travel more easily at the high voltage level because there is less losses. And then step down, and when we have step up for the transmission, then we need to step down the transmission voltage that is suitable for the distributions level, and therefore again require the distribution type substations. So what we understood from here, from this discussion so far, that we are doing the generation voltage is less, the this generation capacity is higher, like this generation voltage is 11 kilo voltage, or max to max we can take 33 kilo voltage this much. And but generating power is higher, like this may go to 600 megawatt or 600 MVA, or the 1000 megawatt or 1500 megawatt. So generation power is higher. So what we understood that here, that we cannot transmit such a huge power and less voltage. So what we required after this generation of the power, we need to have this transformer, and that is we call as the GSUT, generating step up transformer. That also we can call GSUT. And this transformer will have some associated switchgear, that we will put some switchgear on the this side, on the generation side, and we will put again some switchgear on the transmission side. So we step up the voltage, like we take 11 kilo voltage or 33 kilo voltage, whatever we have generated. So we can take 33 kilo voltage, and that voltage we step up to 400 kilo voltage or 220 kilo voltage, based on that how much power we are going to transmit, 400 kilo voltage, and how much length we are going to transmit that voltage. And then this 400 kilo voltage we feed to the bus, and from the bus we electrical bus, or we can directly feed this to the grid also. And from here we take a 400 kilo voltage line, and through that we have the switchgear also here, associated switchgear, and then we transmit. So what we have after the generator, we understood that to step up this voltage we require the generating substations here. We require the generating substations here. So this is why the substations comes into the use. Now we have stepped up the voltage. We have stepped up the voltage. This voltage we transmit to some 100 kilometer or 200 kilometer length. So this voltage we are transmitting. And now to receive this high voltage, again we have one transformer that take this high voltage 400 kilovoltage for 220 kilovoltage for example, and that we convert into this again less voltage, it may be 220 kilovoltage, and then they may feed to different geographical region. They may feed to different geographical region. This is one geographical region. So here we have the transformer that take 220 kilovoltage as the input, and step down to 33 kilovoltage, 132 kilovoltage, whatever we require as per the load of that area. and then again this 33 kilovoltage we can feed to the consumers and to the industry. So to facilitate this step down, again here we require the substations, again here we require the substations, and if we are feeding to this geographical region, so again we require here the substations. So I think that this is clear that why the substation is required, and that what we are trying to explain. So therefore, to connect these remotely located power generating plants to the end consumers, we need the chain of substations, generating substation, grid substations, and distribution substations, transmission line, as we can see here, this transmission line, this one, transmission line, and the distribution line, and combination of this network called as transmission and distribution system, or we called as the T&D system. And this is one of the business segment in the electrical system, T&D sector or T&D system. I hope so far I am clear with all of you, right? So we discussed the main component of the power system. Then what is the generating voltage? Then in case of solar, what is the generating voltage? Then why we cannot transmit this low voltage? What is the problem with the low voltage and high power? So here we discussed that why the substations transmission and distribution is required and how it comes into the use, right? Yeah, Ganesh, thank you. So we can have a review now on this power system component. Here we have the generating power plant sending into substations, generating substations. Now this portion we have the generating substations, and we step up the voltage with help of this is the transformer. We step up the voltage to the that is scheduled for the power transmission. It may be 132 to 2400 765 kV. It depends that how much power, how much length, and how much power we need to transmit, right? So this is the transmission network, and then again here we have this primary grid that is taking 220 kilovoltage to step down to 66 kilovoltage, and then this 66 kilovoltage again they are transmitting, and that is the secondary transmission, 66 to 132 kilovolt. This is the secondary transmission, and then we have secondary grid that is taking 66 to converting to 11 kilovoltage, and this 11 kilovoltage here we have this distribution substation that take 11 kilovoltage convert to 415 voltage, and that they are feeding to the commercial industrial customer, feeding to underground cable through the urban customers, residential customer, and then it is also feeding to the uh, residential customer. So these are the total power system network that we have, right? Okay, so now when we plan this transmission, when we plan this yeah, okay, Rahul. So when we plan this transmission, this transmission line, so to plan this transmission line, first of all we have to do the route survey. So here we have taken one example of the route survey. This is, I think we have some route survey document also. Yeah, this is one report, survey report, and the RA drawing, the route analysis drawing. Geoinfosys is the company who have done this route survey for the transmission line, and based on the route survey they will propose the transmission route, selection of the criteria for the transmission line route. The alignment of the transmission line should be most economical from the point of view of the construction and the maintenance. The alignment of the transmission line selected should be shortest possible one. So based on the route survey they are going to propose, or this surveyor will propose the routes, the possible route for the transmission line corridors. So here we can see their proposals about. So this is one 400 kilovoltage route survey report. Yeah, and comparison of the three alternative routes. So here they have put the proposal for the this Kasargode DC means double circuit transmission line. So they are putting the transmission line. They are putting the transmission line or connecting the transmission line between the Mangalore, the ODP PCL to the Kasargode 400 kilovoltage quad DC. This is generating plant. This is the substations. Now to put the transmission line here, we have the transmission line route proposed. So alternative 1 proposed red, alternative 2 green, and alternative 3. So 3 route they are proposing. That line length, how much required, the route length, that is 127 meter, number of angle points in that transmission, the protected forest area 3014 meter, the density of trees, other how much density is so high of the tree, wildlife century nil, number of river crossings, number of national highway crossings. So by considering all these aspect, we plan this transmission line corridors for connecting this trans for this generating substations to this distribution substation, right? So, as to connect remotely located power generating plants to the end consumers, we need to substation and transmission line. To plan the transmission line, we need to perform the transmission line route survey, and based on that, we propose the best suitable route after the route survey. This snapshot we can take as the RA, route alignment report, that is prepared by the surveyor. So to connect this power generating, we have the substation that is step up, then again we are feeding to the primary substations, then secondary substation. These are the transmission line, and then pole mounted substation, and then we are going to users. So we have a chain of the substations. And if we talk about the TND system, that what we have in the TND system, so we have the electricity generating stations, then transmission and substations, then transmission line, transmission substation, then transmission line, then distribution substations, then distribution line, and then from the distribution line we are feeding to the industrial consumers and then residential consumers. So these networks we call as the TNT system, right? So why we require the transmission line, why we require the substations, and why we require the distribution line. So let's have a conclusion on that, quick review. So we require the substations. Purpose is to step up the voltage at generating station by generating substations, and step down the voltage at consumer end, and that is called as the distribution substations. It means the substation is nothing but transferring the power from generating station to the transmission system, and from the transmission system to the distribution system. That is the use of the substations. And along with the substations, also along with the transmission, the substation also perform the protection of transmission line system, voltage control of the transmission line, reactive power compensation, security the supply by providing the facility for charge for changing transmission path. So that is the use, that is the other function that we can achieve with help of the substations. Now when it comes to transmission line, so purpose is to transmit the power over a long distance, and this transmission line for the two type, primary and the secondary transmission voltage range is starting from 66 to 765 kilovoltage. So what is the maximum transmission voltage that we have across the world globally? So we can see that this is my generating voltage this much, and what is the maximum transmission voltage?
1200 volts.
Yeah, so we can see the maximum transmission voltage that exists in this world globally, that is 1200 or 1150 kilovoltage. And fortunately this voltage is exist in India. We have this system in the India. Before India, it was China who have the 1100 kilovoltage, because these country have large geographical regions and they have huge pollutions, and that is why they need the higher voltage for the power transmission. So China have the 11 kilovoltage. Thereafter India comes and they generate 1150 or 1200 kilovoltage, and that is the most highest voltage at present in the world. Yeah, 150 correct, Rahul. 150 is the highest voltage, and this plant is based in, I think it is in the Madhya Pradesh, MP, and in Bina we have this testing line on of this 1150 kilovoltage. So 1150 or 1200 is the rated voltage. Nominal voltage is 1150 kilovoltage. That is the maximum voltage that have in India. Plant based in Madhya Pradesh. Place name is Bina. I think this. And before that, it was China that have 1100 kilovoltage. The reason is the huge pollutions and the huge geographical regions. Due to that, they have very huge voltage for the transmission purpose. Yes. So 765, and what happens that 1150 is the testing that maximum voltage that exists, but mostly the transmission voltage, operational transmission voltage in India are across the world is 765 kilovoltage. That is mostly operating transmission voltage. So even though we have 1150 kilovoltage, but mostly the maximum range is 765 kilovoltage that mostly uses. 1150 is very less. And then distribution type, further again we have two type of the distributions line, the primary distribution and the secondary distribution. The purpose of primary distribution is to feed supply to the industrial consumers and to big consumers, and the secondary distribution's purpose is to feed supply power to domestic and the small end consumers. And the distribution voltage that 33, 11 and 415 voltage, that is we have the distribution voltage. So what we discuss, the generation again we do 1133 kilovoltage, and then for the power transmission we go up to the 1150 kilovoltage, and the various voltage that we have, the various voltage that we have, that is if generation, if we talk about the generations, so already we have seen that is 3.3 kilovoltage, 6.6 kilovoltage, 11 kilovoltage, 20 kilovoltage, and 33 kilovoltage. And when it comes to solar, so it may be 300, sorry, 600, 800, or 1.1200 voltage in case of the solar. This is what we generate. And when it comes to the transmission, when it comes to the power transmission, so what the voltage we have, and that voltage we are achieving with help of the transformer. So here we use the step up transformer. We feed all this voltage and then we step up. So what voltage we can step up? It may be a 66 kilovoltage, 132 kilovoltage, this 220 kilovoltage, yeah, 1110 also, 1110 kilovoltage, 400 kilovoltage, 765 kilovoltage, and 1150, but that is very less, 1% we can say like this. And when it comes to the distribution, when it comes to distribution voltage, so what voltage range we have, that is again 33 kilovoltage. So again we require the substations that take all these voltage, and then step down to this 33, 11 kilovoltage, and again we required this secondary distribution that take this 11 or 33 kilovoltage, step down to 415 voltage, and that we feed to the domestic consumers. So this is overall our electrical power system network. I hope this is clear to everyone, right? So what we discussed, that why generation voltage is less, that we discuss, right? Why generation voltage is less, that we discuss, because the huge power we cannot transmit with the less voltage. And why we generating the less voltage? Due to the limitations of the equipment, limitations of the transportation of the equipment, limitations of the O&M facility, we cannot generate all this voltage. So we generate this much voltage, then we have the step up transformer, we step up for the transmission purpose, and for the long transmission we require the higher voltage. So that power, we know the power formula, that is P is equals to root 3 into VI So if my voltage is reduced, voltage increase, then current will be reduced, and all the losses depend on the current. So the all the line losses will also able to reduce, right? So we transmit to the higher voltage, extra high voltage or ultra high voltage. Then we again step down to suitable to 3311 kilovoltage that is placed near to the end consumers, and this we feed to the industry. This we feed to the industry also, and from this 11 kilovoltage we can take, or this we can take, and then again step down with help of the pole mounted substation. This is the pole mounted substations, and we step down to 415, and then we feed to the end consumers. So I hope that the entire power system network is clear to all of you, right? Yeah, please.
Hello.
Yeah.
Sir, I have one doubt.
Yes, Rohit.
Sir, from generating station, if we are generating 33 kV, okay,
Hmm.
so how it is transmitted means 33 kV to how it is step up to 132 kV
With help of the power transformer, Rohit. With help of the
power trans.
yeah, you can see in this drawing also. You can see in this drawing also. We are using this step up transformer right now.
Yes, yes, sir.
So this will step up to 132 kilovoltage or 220 kilovoltage with help of the step up transformer, and that transformer we place into the generating switch yard. So
Okay.
we have one generating substations, and that is generating substation take the power from the generator, right? And then we step up to the 132 kilovoltage to 20 kilovoltage or 400 kilovoltage, and then we feed this to the transmission line. So the power step up with help of the step up type power transformer.
Okay, okay, step up type transformer. Okay, power transformer.
Yes.
Okay, sir.
Okay, Rohit. Any other query so far? I think this is clear. This is basic, very basic. We are going to that is the only introduction of the electrical power system network that we are going through, and we discuss that why.
So one question is there.
Yeah,
The transformer will be start delta or delta delta?
this transformer, sir. Let me come to where this one,
No, no,
this.
just the previous picture. Yes, yes, this one, this
Yeah.
one.
So, sir, actually, what happened? This trafo have the delta on this side, on the generator side, and it will have the star on the transmission side, and this will be earth with help of the neutral grounding reactor NGR, and it will go to the earth. So this will be Y and D1 delta this side, star this side. And now you can ask me why this we are taking. So I will explain in the next session, sir, when we have the transformer cell session. So I will explain that why we take Y and D1. Okay, Mansoor sir. We take delta on the generator side. That is the point. Because we wanted to block the third harmonic or multiple of third harmonics and the zero sequence current. That is why we prefer to have the delta on the generator side. Right, Mansoor Khan sir? Now,
Yeah, yeah, got it. Thank you.
okay. And no, sir, we will have the detailed session on this transformer, and every point we will discuss with help of the ETAP also. Okay, sir. So transformer selection, sizing, and the protections. So here we have this vector group selection. So we'll discuss at that time how to select the transformer vector group. Okay, so
Excuse me, sir.
yeah.
So I have one question. In that route survey report, there was B line length. B line length there was mentioned in that route survey report. So can you explain that? What is that? In that? Yeah.
Mhm.
B line length. One number. Yeah.
That is my what I can say transmission line length.
Uh, the second one is I think the transmission line length, and the first one I think they all have same one. same line length. So I didn't
This is
get
the
that.
route. This is the route that we need to follow, because this is my total shortest line length. We can say, yeah, that is the required line length, shortest
Oh,
line length, and this is the route line length that is available.
okay, 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 sir. Thank you.
So this one is the shortest that is connecting from plant to the transmission to the substations. But this is not available, so we are following these
Yeah,
routes.
yes, I got it. Okay.
Yes. Okay, so we have, in if my generator power is test station, that Silpa, I'll come on that. Okay, let me take the queries now. If my generating power is 500 megawatt and my requirement is 250 megawatt, then my generator will deliver 250 megawatt or 500 megawatt. Yeah, it will deliver as per your requirement only, Soumya. This is your 500 megawatt is your capacity, but you can take the 50% of capacity. It will deliver 250 megawatt.
Okay. Okay, sir. Thank you.
Yeah, and about the 1200 kilovolt transmission line being test station. So can you please elaborate about what is the test station, Silpa? Is that where we put the transformer, where we put the transmission towers, and and we do that when we applied the 1200 kilovoltage on the transmission towers, on the equipments, on the transformer, so whether that equipment is withstanding the 1200 kilovoltage or not. So for that we have one test station. Okay, Silpa, so that we are supplying the voltage to all the equipment and we are doing testing that whether equipment is withstanding or not withstanding. Similarly, we have the testing station of the tower also. So we applied the load on the transmission towers and we see that whether tower is withstanding or that the tower is bent or it is fall down to earth. So like these tests we perform in that testing stations. Okay, Silpa, so hope this is clear for you. Okay, Sampath, I'll say the road survey report. No issue. Okay, any other query so far? Okay, so we can go to the, yeah, let me join again here. Just 1 second. Share the screen. Yes. So here again we can see the same power system network that already we have seen. Okay, now the next point that here we discuss about the what is the substations, like purpose of substations, purpose of transmission line, and purpose of the distributions, right? And now let us have that what is the role of generating substations. So this type of the substation gets power supply directly from the generating plant. As we can see here, this is my solar power plant. This is my generating substation that taking power directly from this solar PV cell, right? So this type of plant get power supply directly from generating plant. So here we have thermal, so they are taking plant from the thermal power plant. Here we have power plant again, thermal again, so they are taking power from the directly from the this generating plant, that is 12 kilovoltage. Here it uses a large power transformer for increasing the voltage level for transmitting to the long distance. The generating substation is connect the generators to the utility grid. We can define in a single statement that what is the generating substation. So that connect the generating substation to the that connect generated to the utility grid. So that is the generating substation. So that is the rule of the generating substations. Now next we have the grid substations. So this is the type of the substations we can see. So here we have the grid generating substation that is located near to the generator. Then we have the grid substation, that is grid station is an interconnection point between two transmission line circuits. Those are serving or connecting to two different geographical regions. So as we can see this is one example of the grid substation, that is one geographical region on left hand side, second on the right hand side. So these substance is connecting these regions and this region with help of single power generation source. So this is, we can say, that is the grid substations. Now the next is the distribution substations. So the distribution substations reduces the voltage to a level that is suitable for the local distributions. Thereafter, the electricity must be distributed to reach each house, factory, or the business. So that is the use of the distribution substation. That, so this will take the 132 kilovoltage or 66 kilovoltage or 220 kilovoltage, and they will step down to 33 kilovoltage or 11 kilovoltage, and that 11 or 33 kilovoltage we can directly feed to the industries, and directly we can feed to the commerces or end users. This is the use or the role of the distribution substations, right? During the college time we study this kind of the online diagram. So here we have generating stations, then generating 11 kilovoltage, then step up transformer. This is here that we are putting. Then step up to 132 kilovoltage. Then step here we taking this 132 kilovoltage, step down to 33 kilovoltage, and then again this step down transformer. This 33 kilovoltage they are taking. Then they are step down to 11 kilovoltage. They are taking 11 kilovoltage. Step down to 440 voltage. Then this is the end consumers. So this is what SLT we study during college time, right? But now if we see this network, like, so we can see like this, or we can see like this generating plant. So here we have generating this transformer, then step up, then we power transmission, then again we have substation that we are taking this transmission, then we step down to 66, then feeding to here, then 66 they are taking this one, step down to 11 kilovoltage. This is taking 11 kilovoltage and input, then step down to 415, and then they are feeding to different end consumers, right? Yeah. So if we conclude that why we have the substations, so the conclusion is that the purpose of substations is to step up the generating low voltage electricity from the generating system and enable for the transmission, and then receive the power from transmission system and step down the high voltage to lower voltage electricity, so it can be easily supplied to end consumer, like industrial consumer or domestic consumers are the uh, through the distributions line. So I hope this is clear, that why we have the substations, why we have the transmission line, and why we have the distributions line, and what is the role of the substations, right? So what we discussed so far, this power system network we discussed, and we discussed so far that what is the role of substations, why we require the substations, right? This we also discuss, and we discuss about the type of the substations, right? Type of the substations. So we have the generating substations that we discuss, generating substations, then we have the grid substations, and then we have the distribution substation, right? Distribution substation, this we discuss based on the service. This we can divide in this three part, the substations. Now based on the locations, based on the switchgear, again we can divide. So type of substations used based on the installations are based on the insulating medium. So we have the outdoor AIS type substation. AIS means air insulated substation, that is located outdoor. So this is the example of the AIS outdoor substation, this one, this snapshot. Thereafter we have the indoor GIS type substation. So that is the picture for the indoor, that you can see that is placed in a RCC building, indoor GIS type substations. And third one we have the hybrid type substation, and that hybrid type substation is the combination of AIS plus GIS. So as you can see here, in case of AIS we are taking 20 meter of the distance to place the switch gears. So when we use the hybrid, so few equipment we can combine together, and this 20 meter reduced to 12 meters. So when we have the enough space, we go to the outdoor AIS. When we do not have the enough space and we have the polluted environment, in that case we go with the indoor type GIS substations. And when we have the space but we do not want it to go into GIS, but we have limited outdoor space, in that case we go with the hybrid type substations. So this is, again, we can divide the substation based on the type of the insulating mediums.